Hi everyone, welcome back. Today we're talking about section 7.4 and we're adding and subtracting rational expressions. Before you were multiplying and dividing. Today is adding and subtracting. So pretty much you have to remember, well, you have two fractions and you are adding them together. What do you need to have? Well, that answer is common denominators, of course. So in our first little example, how do you add fractions? We need common denominators. If you see 3 divided by x plus 1 plus 5 over x plus 1, you'll see right now we have common denominators. They're the same. So you keep the same denominator, and then you're going to add across your numerators. So 3 plus 5 gives you 8. So your fraction would just be 8 divided by x plus 1. Now, there's a little caveat. You have to make sure that x cannot equal -1 or your fraction is undefined. So, today our core concept is to add and subtract our rational expressions. So you'll see adding and subtracting, they're super similar. If you had your addition, you find common denominators and then add your numerators. With your subtraction, you find common denominators and subtract your numerators, just as long as your fraction is defined. So C couldn't equal 0. In our first few examples, we'll just go right into it. We've got denominators that are both 21x, so you just add across your numerators. So 5 plus 2 gives you 7 divided by 21x, and that will simplify to be 1 over 3x. And that's just as long as x does not equal 0, or your fraction would have a 0 in the denominator. In our part B, we've got x minus 5 as our denominators, so you're just going to subtract, I don't know. So you just subtract across your numerators. You get 4x minus 3 divided by x minus 5, and that's just as long as x doesn't equal positive 5. So moving on. The fun begins when you have to find common denominators. All right, so we're going to actually skip this example 2. We'll come back to it. Let's put it into play. In example 3, you'll see that you have denominators that are 9x squared and 3x squared plus 3x. Somehow we have to get common denominators out of those. My suggestion is to first, zoomed in, factor them. So you can see what sort of common factors they both have. So the first fraction I'm not worried about, but over the second fraction, I can factor out a factor of 3x, and my leftover would be x plus 1. And your numerator stays as x. So then you have to ask yourself, well, I have to make both of these fractions have a least common multiple as the denominator. So let's see. I'm just going to set up my framework here. I'm going to take my least common multiple, so between 3 and 9. Okay, is there anything I can multiply that 3 by to get the 9? And that answer is yes. So I can make both denominators have a 9. And then move on. You have x squared and an x. Okay, is there something I can multiply a single x by to get x squared? Yeah, it would just be x squared. So really you want to make your common denominator have the highest degree. If you have a degree of 2 and a degree of 1, you're going to take the bigger one. You're going to take the x squared. If it was between x to the 4th and an x squared, you would take the x to the 4th. And then the last factor we have to have as x plus 1. Everybody has to have an x plus 1. So now we've made common denominators, but technically I have to multiply my fraction so I have common denominators. So I pretty much asked myself, I need this, 9x squared times x plus 1. I only have 9x squared. So what do I have to multiply the numerator and the denominator by to get that extra factor of x plus 1? So I'm just going to multiply by a giant 1, technically, of a factor of x plus 1. So in my numerator, I would have 7 times x plus 1. And then I go to my next fraction. And I take a look. I have 9x squared times x plus 1. And I have 3x times x plus 1. What do I have to multiply to get that common denominator? And you would say I would have to multiply by a 3 and an extra x, which is just multiplying by a giant 1. And your numerator would just be 3x times x, which is 3x squared. All right, so once you're at this step, we have common denominators now. We can just add across our numerators and keep the same denominator. So compile everybody into one fraction. I'm going to distribute up in my numerator. That would be 7x plus 7. And add in my other numerator of 3x squared. So now I'm at the point of rearranging my terms just a little bit. So I get 3x squared plus 7x plus 7 divided by 9x squared times x plus 1. Now this is all true as long as x doesn't equal 0 for the x squared factor, and x cannot equal -1 for this factor down in the denominator. All right, well, you hung in there. Let's try another one. Got extra example 3 here. My recommendation first to find your common denominator is to factor. So the first fraction, don't worry about, but you can factor out an x out of the denominator of your second fraction, and you have x up top. Now, one option is you see the x and the x, those can actually cancel right there. So that would be 1 divided by x plus 1. I'll write it over here. To simplify your life a little bit, oops. Now, you think of the common factor between 12x squared and x plus 1, and you end up just multiplying those denominators, which is a valid option for you to always do. So your common denominator would be 12x squared times x plus 1. So we'll make both of them 12x squared times x plus 1. And then you have to think of, what do you have to multiply each fraction by to get that common denominator? So in my first fraction, I have 12x squared. I'm missing a factor of x plus 1. So x plus 1 times x plus 1. And again, that's not changing the problem. That's just multiplying by a giant 1. And then in my second fraction, I have to multiply by 12x squared. Numerator and denominator. Again, just not changing the problem, just multiplying by 1. And then I have my common denominators, so now I can just add across the numerators. Now it would be 12x squared plus, I'll distribute 8x plus 1 divided by your 12x squared times x plus 1. Oops, I didn't draw 8. All right, so we're at this point, And I do see I can factor out a greatest common factor between, in my numerator, the 12, the 8, and the 4. So I'm going to take out a 4 multiplied by 3x squared plus 2x plus 2 divided by 12x squared times x plus 1. And I can actually simplify. So the 4 and the 12, that goes down to 1 and a 3. So my final answer, we've got 3x squared plus 2x plus 2 divided by 3x squared times x plus 1. And that's just as long as x does not equal 0 or negative 1. All right, and example 4, all we're doing is subtracting. So you treat it the same. Factor everything first. So take out a factor of a GCF of 2, you'll have x minus 1 left. Minus, I'm going to factor out a factor of negative 1 up there because they're both negative. So you're left with, in the denominator, that factors into x, a negative 3, and a negative 1. And right here, that's a double negative. So it actually turns out to be an addition problem. Plus 2x plus 1, and an x minus 3, and x minus 1. All right, so now we need to find our common denominators. So they would just be, set it up. I need a 2. Everybody has to have a 2. Everybody has to have an x minus 1. And this guy has an x minus 3, so he is part of our common factor. And so we need to multiply our first fraction by a factor of that x minus 3 in the numerator and denominator, and make sure that you FOIL that. I'll write it out here so we remember. Add parentheses. And my second fraction is just missing the 2, so multiply everybody by a 2 over 2, parentheses, so 2 times 2x plus 1. And whew, now I think I'm going to trail up here, have some more room. When I add my fractions, I'm going to have my common denominator of just 2 times x minus 1 times x minus 3. And I need to FOIL. First, outer, inner, last. So that's x squared minus x minus 6. And I did that in my head, the FOILing, plus this distribution of 2x squared plus 1 gives you 4x plus 2. So now we're at the point of 2 times x minus 1, x minus 3. Combine your like terms. That would be x squared plus 3x minus 4. And now you ask yourself, can I simplify that fraction? And you notice that your numerator can actually factor now. That'll factor into an x plus 4 times a x minus 1 divided by 2 times x minus 1 times x minus 3. And you see you can actually cancel out that full factor of x minus 1. And you're left with just x plus 4 divided by 2 times x minus 3, just as long as your x doesn't equal positive 3, or even technically positive 1 from this step. All right, I know these are long problems, but you really have to just stick with it and try your best through it, and just make sure that you limit how much you're canceling. So you're only canceling factors, Okay, so like a factor of x minus 1s, or a factor of, x squared, something like that. We can try another example just for extra practice for you guys. You start off, this one similar to the last example, so maybe you want to pause the YouTube and try it for yourself and see if you get the same answer. So we'll start 5x minus 1 doesn't factor. You're left with a factor of x minus 2 times a x minus 1 is the denominator of your first fraction. And a similar situation, I'm going to factor out a -1 in that numerator and actually end up with just 2x plus 1 divided by, factor out the 2 in the denominator, x minus 2. So this again will create a positive. So you're left with 5x minus 1 divided by x minus 2, x minus 1. So plus 2x plus 1 and 2x minus 2. All right, so now we're at the point of common denominators. So what would my common denominator be? I'm going to take a 2. Everybody has to have a 2. Everybody has an x minus 2, so we keep him. And I need an extra factor of x minus 1. So this is called the least common multiple, okay, that you make your denominators. Now let's multiply our first fraction by the extra factor of 2 over 2 that we need and add parentheses. So 2 times 5x minus 1. And my second fraction is missing a factor of x minus 1. So multiply numerator and denominator. Add some extra parentheses. That gives you 2x plus 1 times x minus 1. Now keep going. I'm going to distribute and combine our numerators. Distribute, FOIL. Going to keep that same denominator. 2 times x minus 2, x minus 1. And that first fraction will give me 10x minus 2. And the foiling will give me plus 2x squared minus x minus 1. And just combine your like terms. You're almost there. Hang in there. 2 times x minus 2 times x minus 1. And my numerator would just be 2x squared plus 9x minus 3. And you can try and factor that numerator and it's not going to work. So we need to just disclose that x can't be 2 and 1, or your fraction's undefined. Now, I know I skipped over example 2, so now we can look back. Example 2 is asking for what the least common multiple between two terms are, or two expressions. So pretty much it's taking out the denominators and saying, what does the denominator technically have to be? Like, what would your least common multiple be? So it kind of sucks out making common denominators out of context. So now I think once you do the problem, you can understand what's happening. That imagine 4x squared minus 16 was a denominator, and another fraction had a denominator of 6x squared minus 24x plus 24. You want to sit there and you want to factor these. So 4x squared minus 16 is factorable. You can take out a 4 and you're left with x squared minus 4. And then you notice that the x squared minus 4 is actually just a difference of two squares. So that'll fully factor into x plus 2 times x minus 2. So imagine your one fraction had a denominator of this. Now, over to the right, we're going to factor out a GCF of 6 first. 4x plus 4. And then we're going to factor that polynomial. We've got 6 times x minus 2, and an x minus 2. So that one's a perfect square. Now, you need to find the common denominator, which they call the least common multiple. So you want to take one of each of the factors. And if there's a factor that's repeated, take the bigger one. Okay? So let's just start off. We've got a factor of 4. We've got a factor of 6. Okay? 4 is 2 times 2. And 6 is 2 times 3. So the 2 times the 2 is what we're going to take. We're going to take a 4 multiplied by the 6 has a 2 times the 3. So the 4 takes care of the 2, but we need a factor of 3. And then just go one by one. We need an x plus 2 factor. Right? And then right here we have one factor of x minus 2, but over here we have 2 factors of x minus 2. So we're going to want to take the bigger exponent. So we're going to make our common denominator the factor of x minus 2 squared. And that's equal to 12 times x plus 2 times x minus 2 squared. And I'm going to leave it like that. You do not have to FOIL that out. That will take forever. I'm not in the business to torture you, okay? Even though today might seem like it. Let's try an extra one before we head out. So 6x squared minus 54. Factor out a factor of 6. So 6 multiplied by x squared, your leftover would be a minus 9. And you see that one's also a difference of 2 squares. So you get x minus 3 times x plus 3. And the expression to the right, you're going to take out a 9. So 9 times x squared minus 6x plus 9. And that one is also a perfect square. So it would be x minus 3 times x minus 3, which you could really condense into 9 times x minus 3 if you want, or x minus 3 squared. So your least common multiple, okay, go term by term. 6 has a 2 and a 3, whoops, and the 9 has a 3 and a 3. So we're going to take the bigger power. So we're going to take the 2 multiplied by 3 squared multiplied by everyone has an x minus 3, at least one of them. So we're going to take x minus 3 squared, the bigger power, and everybody needs a factor of x plus 3. And then just simplify that down a little bit. You got 18 multiplied by x minus 3 squared times x plus 3. And you're all done. So just remember, if you see problems where they're asking for the least common multiple, it's really just adding the fractions or making common denominators out of context. Okay? So, little parenthesis. I wish you all the best. I hope you are all well.